Ethereum is a programmable blockchain. You have smart contracts. You can build whatever application that you want, right? So you have programmability, but you don't have privacy. Zcash, on the other hand, is not a programmable blockchain. It just allows payment. It's like Bitcoin. You can do payments, private payments, but you cannot have programmability. So this marriage between privacy and programmability is what's exciting, because now you have the privacy, but also you have the exciting, unlimited possibilities of what you can do with this private money.
So this is by far the most information-packed podcast I have ever done. This episode is a conversation with Mohamed Fouda from Allianz on privacy in Web3 space, and what are the cutting-edge technologies that enable privacy, and what are the most innovative projects in the space that are leveraging these technologies to build cool solutions using privacy. So Allianz is a leading crypto accelerator and founder community, and Mohamed has a background in electrical engineering with a PhD and a lot of experience in designing circuits using FPGAs and designing ASICs and chips. And he is also active in crypto space since 2013, 2014, working with a lot of founders. So we are currently seeing an acceleration in these technologies that enable privacy-based solution, especially due to the advances in the hardware. And Mohamed is one of the few people in the industry who's well positioned to give you a perspective on these technologies and projects with his unique background. So without further ado, let's get into this conversation with Mohamed. Today, we are having Mohamed Fouda as our guest. He's the head of research at Allianz. Allianz operates as a Web3 accelerator and builder community. Allianz focuses on supporting and accelerating the growth of startups in the Web3 space. Welcome to this conversation, Mohamed.
Yeah, thank you, Suraj, and thanks for having me.
Yeah, thank you for being here, because this is one I'm really fascinated by your writing. I'm a regular reader of your Medium articles, and it's fantastic. It somehow unfolds the technological advances that are happening in the blockchain and Web3 space, especially zero knowledge proofs and other ways to do a verifiable computation and privacy. And recently you are writing a lot about Bitcoins and L2 space. That's also fascinating. In this episode, we are focusing on privacy and the different ways to achieve privacy and why is it important and stuff like that. So I'll before I go into the technical details, and I'd love to know how you came into this field of blockchain and Web3. And I have read that you are an engineer by training. So how did you reach here from that position?
Yeah, it's a kind of funny story, because I never believed, or like never anticipated, that I would be working in crypto full time, almost like everyone else. As you mentioned, my background is electrical engineering, so I have been always in this field. I had an undergrad, master, and PhD, all in electrical engineering, and my focus was actually on a very specific area in hardware design. Initially, I designed circuits using FPGAs and stuff like that, and then I went even deeper to design ASICs and the chips. And during my PhD, I was working even on the lower level in designing on the semiconductor and studying semiconductor physics itself. So my field was not software. I didn't write code. I didn't have any deep education in cryptography, for example. So it wasn't an easy transition. But during around 2015, 2016, I discovered about Bitcoin, and I didn't understand this magic internet money. So I did what I do best, which is research. So I went and found articles and found resources and kept reading about Bitcoin for a few months until I finally understood how Bitcoin works and like what is the vision of Bitcoin. And the rest is history from this point. I believed in Bitcoin vision. Ethereum was new at this point, and I got hooked into Ethereum. And my focus since then has been into diving into the technical details of projects, assessing these technologies, and estimating the power of this technology and what can be done with them. And I have been always on the technical side and technical diligence side. And eventually I joined a venture firm to invest in some companies, in Web3 companies or crypto companies, which was called Bold Capital. And since then I have been in the space. Currently, as you mentioned, I'm with Allianz. And with Allianz, I work with many founders, many companies that build different aspects in crypto. And this kind of forces you to widen your scope and learn more technologies. And yeah, my day-to-day job is to actually be on top of this technical narratives and what can be achieved with them. And that's why I visited privacy topic, which is actually close to heart. I also very interested in intersection between crypto and AI, which also have strong relations to privacy, as we will discuss today. And recently, the biggest trend in the crypto space is Bitcoin L2s and what they can enable. So this is kind of what I do. I focus on the big narratives.
Yeah, that's why I love your writing and makes it easier to understand where the space is moving, where the technology is progressing. Why is privacy important? When we talk about privacy, regular folks understand something like Zcash or Monero and stuff like that. But I think privacy goes beyond that, not only for important for cypherpunks, also for
Mhm.
normal individuals, companies, businesses. Etc. Why is privacy important?
Yeah, you actually raised a really good point. When you say privacy, especially on blockchain, people think typically of privacy of financial transactions, Zcash, Monero, all this token, because people think that, okay, privacy is only how to keep my transaction history or my transactions private. But the reality is that the surface of the privacy problem is what is much wider, especially at this moment when we are trying to recruit a billion user to crypto, and we are seeing more of the non-financial applications being built on blockchain rails. But the privacy here, I will just roughly categorize it into two buckets. The financial application we know. You don't necessarily want to have your all financial transaction tied back to your identity, right? When you are in the real world, when you're using a bank to do your financial transaction and pay your bills, the bank doesn't take your history of transaction and publishes everywhere. They are kept private in the bank, right? Unless the government want to see them, then the government or the tax authorities want to see them, then the bank can provide them. But other than that, your transactions are private. When you move your transaction into Web3, let's say that I want to pay you some ETH or some USDC, there is no way to hide it. This transaction will stay in the ledger. And if I use this address once, all this transaction related to this address, you will know them because you know my address now. So, of course, this is not an advantage if you are using cryptocurrency for everyday uses. If you are a freelancer and being paid for your work by cryptocurrency, you don't want everyone in the world to know your income. That's a bad. And even more for businesses, as you mentioned. Let's say that you are a company that providing services or making a goods or selling services, and you have your client list. You don't want to tell your competitors about your clients and how much they are paying you for your services, right? If you don't have privacy for payments, you essentially will be telling every competitor on earth, like, who are you dealing with? Who are your suppliers? Who are your customers? And how much you are paying them. So on the financial side alone, privacy is not like a luxury. I would say it's a fundamental because it can affect your competitiveness of your business. It can affect your safety, even if everyone knows your income. So on the personal side, I would say it's really important for privacy. But even if we just leave completely the area of financial applications and focus on other non-financial applications, in social media, we send messages to everyone. WhatsApp have end-to-end encryption because no one wants to see your messages. If we are building social apps or social media on top of blockchains, this message somehow have to be encrypted. It has to be private. If you are even playing games, you don't want to reveal your game state or what is your status in the game to your competitors in the game. So privacy goes a very long way, and that's why I think that is a main reason privacy is picking up steam, and many entrepreneurs and many VCs are supporting this direction.
To achieve privacy on blockchain, what does it mean to be private on chain?
Yeah, that's actually an excellent question. Like, depending on the use case, what you need to be private on chain can be very different, right? And the technology will have to be changed or completely you have to use a different technology. So if we speak about the very first use case of privacy on a chain, which is something like Zcash,
Hmm.
the privacy here meant two things. The privacy of your transactions, which means that if I send someone money, I don't want to disclose the amount of the money. So the privacy of the content of the transaction. Another level of that is actually privacy of the transactors or people who make the transaction. Like, I need to have privacy and my recipient of the transaction have to have privacy, which is another level, because now you are not just hiding the amount or the content, you are hiding who is dealing with the blockchain, who is transacting, the addressees essentially. And something like Zcash provided both. It was clunky, the user experience was really hard, but Zcash provided any user the ability to create private addresses, the Z addresses. And also, and once you generate these Z addresses, now your transaction can be private. You can send a message or send the transaction from a Z address to another Z address uh, with private content, with private payment. And no one on the blockchain, even the nodes that validate the blockchain, will know who did this transaction. So this was the top privacy. Of course, you can change this a little bit by focusing only on the privacy of the message. So Tornado Cash on Ethereum focused more on hiding who transacts by depositing your money into a pool, a dark pool, and then people mix their funds. And then when you withdraw from the pool, you cannot tell who actually withdraw money from the pool. So you start fresh after you get out of the pool. So this is a very first use case, which you privacy of transactions. But as the technology improved, we are starting to see more application that deals with what I call shared private state, or some other people call it common private state, which is that we have one private information that all of us can modify by some way, but no one can know what it is. And a very good example of that is a private vote. Let's say that we decided to make elections on a chain. Then every one of us has to have the right to modify the vote. When I vote by myself, I want to change the tally of the vote. But at any point, I don't want to see the result of the vote until the vote ends. Right? You don't go to the election and say, who is winning now? Let's play with the vote. There is now a bigger theme around shared private state that I would think would be more influential in the future.
Oh, yeah. So like this, like on-chain privacy can then open up an array of use cases. I have read through your article, and it describes different ways to achieve different technologies that enables privacy on-chain, like CK, fully homomorphic encryption, multiparty computation, and things like that. And usually when people understand privacy, the typical example comes is the example of CK prover and verifier, and you can prove something without actually revealing the details. But the other two technologies, like fully homomorphic encryption and multi-party computation, are not the common ones. So what are the key differences between these three technologies, and when it comes to applications and the base technological layer, where do they actually differentiate themselves, and what are the use cases where different technologies can be leveraged?
Yeah. Just to begin with, all this technology is new but not new. How? Like this, the roots of this technology is maybe are 20 years back when this technology started.
Yeah.
But these technologies were not efficient for practical use cases when they got invented. Recently, that the improvement in hardware and improvement in algorithms have allowed them to become practical. Zero knowledge proof was the first to come to the market. But before we go into any one of them, I will just address your question. Why are these technologies different, and how are they different? And I would say there are two main factors why you would need to use one technology and not use the others. First is the use case. Are you dealing with a personal private estate, which is I need to hide my private balance, I need to hide my transaction history? This is a different use case than when dealing with a shared private estate. For example, zero knowledge proofs are excellent when you are dealing with a personal private estate. Fully homomorphic encryption and multiparty computation (MPC) are more suitable when you are dealing with shared private estate. So this is one distinction, which technology meshes what. The other part of what technology to use and how to use the right technology is where do you have the data? Is the data, again, personal? So that just lives in your computer only and will never leave your computer or your device? Or this data lives on a shared environment, on a blockchain?
Okay.
So this also will define to some extent which technology is the best for you. So if we want to go into a little bit of details about what each technology means, what does that mean to have a zero knowledge proofs? Zero knowledge proof at a very high level is that I have a piece of data and I want to do a computation. I want to change this data somehow. And I want this change of the data or the algorithms that change of the data to be verifiable, to be correct, or proven to be correct without telling without telling anyone what was the initial data that I used. And the common example of that, you have some private ETH, Suraj, and you want to send me some private ETH. So you have this private ETH and you want to prove to the network as a whole that you have enough balance to send me 10 ETH. And after that, you want to convince the networks that your balance after 10 ETH is become whatever, and that you send this to a valid address on the network. You just didn't burn them.
Yeah.
So this is a computation that you have a balance larger than 10, and that you are sending to a right address, and that you have the right signature to move this asset. These are simple computations. If you can do this computation locally on the computer, but generate a proof to say to the whole network, I did this computation correctly, and everyone can know that they are correct, but no one can know what is my initial balance. That's what zero knowledge proof are. You prove something to the network without revealing the initial data. And that's why the knowledge proofs are very good, excellent actually for this kind of use cases, private payments. And the initial use case, as we discussed, was Zcash. We can discuss also FHE and MPC and their use cases. But if you have any points in this one, on ZKBs, we can address them first.
Like initially, the main problem with CK piece was it was like really computationally expensive to generate and verify. And now over time, the verification part became cheaper and cheaper. And that's why now we are seeing like a proliferation of CK based applications. So in that sense, you also said that if CK has more to do with like private, like a personal, private, like non-shared, like what you call like. So in that sense, what are the main spaces where we can use CK? What are the main use cases that would come out of CK-based private applications?
Now, this technique, because it was for the longest time the only technique that out there that can allow for privacy, this technique was expanded to allow even more complex interactions. Networks like Aztec and Aleo and many others are actually trying to use ZK to build applications around this, not just payments. Zcash started as just payments, which was like, okay, what is the value of sloshing some money around? I pay you, you pay me back. If we can build application, which is programmability, and combine it with privacy, now we have something. I can have my ETH, I can convert it into USDC, still private, and then convert it back to ETH when the price changes. Now we are talking, I can lend my ETH and get a loan against it, all privacy. So when the applications start, now it becomes more exciting. And Aztec is actually doing a really good job on this front, but the system is very complex. Like when I went go into the details of how Aztec works, again, the concept is that every user will hold their private state. But in Aztec's concept, the applications are still public, which means that if you have an AMM, if you have a Uniswap will still, the pools of Uniswap will still public. But what will happen is that when you interact with a pool, every interaction can remain private until the moment that you touch the pool, the transaction, your data can become public. But no one knows how. Okay, everyone will see that 100 ETH or 10 ETH has been converted into USDC. But no one knows who this transaction came from, because the pool is actually executing many transactions at the same time. So you can have many applications. But in Aztec terminology, because again, Ziki is not really good when it comes to dealing with shared private state, the application has to be public. But as you deal with the application, you can remain in the private realm. And that's how Aztec and Aleo are working. Everything is private until you deal with an application.
Okay. ZK programmability. What does that term mean actually?
ZK programmability can be many things, but the simple thing is that when people use this term, or at least when I use this term, I am thinking of the combination of privacy and having applications. So Ethereum is a programmable blockchain. You have smart contracts. You can build whatever application that you want, right?
Yeah.
So you have programmability, but you don't have privacy.
Yeah.
Zcash, on the other hand, is not a programmable blockchain. It just allows payment. It's like Bitcoin.
Yeah.
You can you do payments, private payments, but you cannot have programmability. So this marriage between privacy and the programmability is what's exciting, because
Okay.
now you have the privacy, but also you have the exciting, unlimited possibilities of what you can do with this private money. So, and that's what took Aztec. That's why it took Aztec like 3-4 years now to build their private blockchain.
Mhm.
Same with Aleo. Combining these two pieces is really hard.
Oh, yeah. First time I think I heard CK programmability is when I was reading through the docs of Mina protocol. They have something like CK apps where
Yes.
I'm not so well informed about Aztec or Aleo, but I believe from what I'm hearing is that it's also achieving something similar to.
Yeah. Mina is a funny thing. I'm very familiar with Mina, obviously. And Mina started to use Ziki for a completely different reason.
Mhm.
But recently, because they have done a lot of research and R&D on the Ziki stuff, they started finding that this same technology will be very suitable for applications. Mina started as a way to compress the blockchain history. And instead of you having tens of gigabytes of data to represent a blockchain, you can use the knowledge proof to compress this state into 22 kilobytes, which is minuscule. But eventually, to do this, you have to do a lot of work on the Ziki technology itself. You have to improve the algorithms and improve the proving and verification. And when this was done, it became clear, oh, people can do applications, and this application can run on the client side, it can run on the user computer side. And we can use this efficient Ziki proving mechanisms to prove to the network that these computations were valid.
Mhm.
So now I'm very excited for this direction for Mina, that Mina is becoming a layer where applications can actually run, and the Mina blockchain will become a way to just prove and verify that these applications will run correctly on the client side. It's converging. In Mina, it was ZK for scalability first, but now it's also for application and privacy.
Got it. And one more question I have to clarify when you said in the beginning, like CK is for like private non-shared state and other things are for shared state. But when we talk about blockchain systems, or for example, there's a concept in Ethereum called this shared mutable global state. And
Yes.
when you bring CK-based programmability to there, from your earlier statement that it is not so good with shared states, so how would it work together in that particular?
Yeah, that's an excellent question. As we mentioned, like in ZK, you cannot you have to do the computation on the transparent data.
Yeah.
And this is okay as long as you have the data on your device, because I am the owner of the data. The data, I can get the data on my device, do the computations on the transparent data. Transparent means non-encrypted. I didn't encrypt the data. And then when the computation is done, I would send the proof to the network and I will re-encrypt the data. But the data never left my device. It's a personal data, so it never left my device. When it comes to something like global state, that's tricky. Why? Because if you need to do any computation on this data, this data is transparent, and because they exist on the blockchain. If you encrypt this data, and you cannot do computations unless you use something like FHE. And this is actually why FHE and MPC even became very interesting. The concept of FHE, again, at the high level, is that you have some data, and this data is encrypted. Someone had a encryption key and encrypts data. So when someone looks at this data, they cannot tell what is the content. But still, you can do computations on this data. You can modify it. You can add a vote. You can compare this data. And the result of the computation will be still correct without decrypting the data. So that's like a kind of a magic. You have a global state that is private, and I can run a smart contract, complete a smart contract on this data. The result of the smart contract will be correct, but no one knew what was the data is. So full homomorphic encryption is a really exciting idea, but at the current moment, it is still very computationally expensive. To give you just a high level comparison, if you are doing a computation on transparent data and it takes 1 millisecond, if you do the exact same computation but using FHE, the time will be between 1 second and 1,000 seconds.
Wow. That is 1,000 to 10,000x or something. Yeah.
1,000 to a million. It's a 3 orders of magnitude
yeah.
to 6 orders of magnitude more complexity.
Wow.
And this is not my numbers. This is the numbers of from the best libraries out
Oh,
there, the
oh,
best libraries out there that do that. There is a company called Zama,
okay.
and Zama have developed this have done this amazing work on FHE, and they have a Rust library that performs FHE on numbers, and they used it for multiple use cases, for machine learning and for EVM, and the numbers are like almost 1,000x more complexity.
Oh, that's a big number. Like that means we would eventually need like really specialized hardware, accelerators, and things like that to make it like viable to be used on a blockchain.
And that's exactly what's happening. All this wouldn't have been possible without the advancement in better hardware, this new node, like semiconductor technologies, 3 nanometer and below,
Oh yeah.
and even stuff like GPUs, like projects that are building on this technology, like for example, Enco Network, which is an L1 focused on using FHE for EVM. So you can do all the computations that you do on an EVM, but you can deal with private state. What will make them possible is that you will have specialized validators who have powerful compute nodes that can do this computation in a reasonable time.
Oh yeah. I'm hearing about this project for the first time. So there's a EVM based L1 which is trying to do something like Aztec is doing
But
based
using
on
FHE.
FHE. Okay. But that's very interesting. I must read about
Yeah,
it.
Enco Network was actually an Allianz graduate. So like
Oh,
they
okay. Oh,
graduated from
yeah.
Allianz
Right.
program. They are using the FHE EVM library from Zama, which is a very interesting. And I think they are launching sometime like Q2 probably this year, which will, I cannot wait actually to be, they have the testnet live, but it's very exciting to be able to say, you know what, we can have a private MM.
Mhm.
You have a private pool that you can change, you interact with, and you change the state of the MM without
Ah,
revealing the state of the MM. You can deal with private lending. You can do with private voting, DAO voting, and stuff like that. All of this will be possible with FHE.
wow, fantastic. And like coming to the third technology, and which is multi-party computation. How is
Mhm.
this different from the two, like CK and FHE?
My mental model for MBC is that it's an actually the middle way between both. For ZK, you have to have the data on your computer, but because you have the data, you are the only one who can do the computation. So this is the best privacy, but also the more work for you.
Yeah.
Because if you want to keep your data private, you will have to do all the computations. On the other end of the spectrum, you have FHE. And what FHE allows you is just to encrypt your data and just throw this encrypted data on the network, put it on the network. And now you will have a set of validators who have these powerful nodes
Mhm.
that will run FHE computation on this data.
Oh, yeah.
Yes, the complexity will be 1,000 to a million X
Mhm.
on this data, but you as a user, you just don't care.
Okay.
Someone else will do this. And this will affect the throughput. But what if you want something in the middle? What if I have some data, private data, and you have some private data, and now we cannot actually do this easily, right? Like we need to collaborate together to do compete on our shared data.
Yeah.
But you don't want to give completely your data to the network.
Yeah.
Or like even encrypted. So multi-party compute is a new paradigm where we can share the compute. How? I will contribute my data, I will encrypt them. You will encrypt your data. Any part who is involved within the process will encrypt their data, and we will share the compute between us. Whenever I need some part of the data, I will just send it to you and encrypt it. And the process goes on step by step. At the end, we will have a result. We can collaborate to decrypt the result, but the initial data is still private. Maybe the best use case is to give an example, or the best to explain this. Let's say that you are a company developing a new machine learning algorithm, and this machine learning algorithm is private. You don't want to just make it open source yet.
Yeah.
And let's say this machine learning algorithm is used to diagnose diseases. You
Yeah.
want this model to be proprietary. You
Yeah.
want to keep it private. At the same time, your users have their medical data, which is
Mhm.
obviously private. You
Yeah.
cannot put this medical data on a chain. So the user has private data and you have a private model. How would these two work together?
Oh
It's
yeah.
really hard.
It's really a hard
So
problem. Yeah.
yeah, it's a hard problem. But MBC gives you a way because now you have your private model, which is at the end of the day, some data, weights of the model. and I have my private imaging, X-rays, MRIs, all of that stuff, and I keep it private. What we can do is to do an MPC between us. Like you want to run your cancer diagnosis model on my imaging data, and we will see this imaging has cancer or not, something like that.
Okay.
So we can work together. We can do the compute. As a user, I will not get any visibility onto your model. As a model owner, you will not get any visibility on my private medical data. But at the end of the day, we will find a data that is encrypted still that tells us the result of the computation. We can agree, of course, to decrypt the result.
Yeah.
Right? We will see if this imaging of this inference gave us cancer or not. But we knew the result and we didn't leak any data from the inputs. So MPC is exactly like that. It's a middleware. We share the load of the compute and we still maintain the privacy, and we have the same outcome. We have the result decrypted.
Oh yeah, that's fantastic, because I was reading about some information leaking attacks on ChatGPT, which can, I read a paper that there was I think it came around 1 or 2 months ago. So there are like certain kind of attacks you can do on AI models to reveal some private data. So in that context,
Wonderful.
when AI gives you opportunities to develop algorithms which can train on some really valuable data like patient data, that could give a lot of advancement in the medical field. But because the details are private and there's like a chance of leaking it, there's always this problem that how are you going to use those details for the benefit of advancing the medical science or any such field. So in that sense, a multi-party computation, as you described, provides a possible solution to that, right?
Yeah, and the interesting part that the technology also is advancing as the efficiency of MPC protocols is advancing, and we have a couple projects like, for example, Nelion network is a network that are trying to use MPC. They have their own version of MPC that can be used for this use case, and in top of that, we are seeing many action protocols trying to use MPC for specialized use cases, not for something as big as machine learning. But the biggest use case so far in the crypto world for MPC was that let's create this secure wallets.
Oh yeah,
Like we can share
Fireblocks.
shards of the keys, and now
Yeah.
when we all collaborate on signing a message, we will sign a transaction as ports, as if it's a multi-sig, but it's more secure even as a than a multi-sig.
Yeah. And I think Fireblocks is one of the examples of multi-party computation. And
Yeah, Fireblocks was one of the largest companies, but now we actually have multiple protocols that do that. In Allianz, we have a company called 0xPass, which is developed a passport protocol. It is a network that anyone can come and say, okay, I will create an MPC wallet and we will collaborate on signing messages or do adapt interactions. Also, there is lead protocol. There is so many variants now. And I'm very excited about that because MPC avoids a lot of risks for users because you can leave one of the shards with a security company that have no ability whatsoever to steal your funds, but they have the ability to simulate the transaction and see if you are interacting with a malicious protocol or with a protocol that maybe not secure. And if they did that, they can just withhold the signing until they make sure that that's what you really want. So it has very interesting use cases.
To end the point with the multi-party computation and the rest of the technologies like FHE and CK. So do you think that the main way in which AI and crypto would be coming together is by leveraging multi-party computation?
I think, one of the things that makes me is super excited about privacy technologies in general, whether it's MPC, FHE, or even zero knowledge, ZKBs, is that the more we try to bring AI on a chain, the more this problem will be more important. Look, so for example, when you go and connect to ChatGPT now, again, you are sending your inference data or your inquiry to OpenAI. And OpenAI, as a company, have regulations and requirement to keep this data private. But the data is private to the public, not private to them. They still have access to this data. If you try to bring machine learning on a chain, that means that you will have somehow to interact. You send your data or inference requests all the time to a blockchain, and you cannot do this. This means that you are leaving your data private or like in front of everyone, public to everyone. So if we bring AI on a chain, which will happen in many forms, I think Vitalik has an excellent post on this one, on what levels will AI exist on a chain. It can complement a smart contract. It can be helping you to find the best DeFi strategies or whatever. You need somehow to protect the privacy of these inputs. And I think MPC and even some part of the ZKBs would be very good for this use case.
I had one conversation with Brandon Case from Own Labs, and he said as of now it's very expensive to run machine learning algorithms on CK circuits because
Yeah.
it's already expensive, and when you put ML on that, then it becomes like incredibly expensive. But I have heard about like projects like CKML, which is working on combining CK and machine learning. And
Yeah, one way actually, like we also we have Modulus Labs, which is one of the leading teams building in the ZKML space. And in Modulus, let's say that you want to use a machine learning algorithm off a chain, but you prove on a chain that this machine learning algorithm has run properly. That's ZKML. You prove of it on a chain what has been computed off a chain. And has immense potential for the future. But because of the initial high complexity, I think there will be some stepping stones, some steps that we can take to reach to the ZKML to be able. ZKML will work very nicely for small models, maybe models that are less than 1 billion parameters. But if you go above that, which most LLMs, the smallest LLMs that I have seen around there, 7 billion parameters or something like that, it will be still hard to use ZKML. But there are other ways that can allow you. There are ideas now to use what we call trusted execution environment, TEEs, which is specialized hardware nodes that are secluded. You can do compute inside them that the rest of the software will not know about. So, and you can approve, the TEEs can provide attestation of this computation, like that this software has been run inside the TEE.
oh, yeah.
I think TEEs and using machine learning model inside the TEE will be an intermediate step in the future of until we improve ZKML even further to be able to run large language models and photo generation models and stuff like that on a
Oh,
chain.
yeah. Excited to hear that so many projects are working on solving these kind of problems. And moving towards the regulatory part, as of now, you are seeing things like MICA from the European side, and even eventually from the US side, something will come that concerns on-chain transactions or things that runs on-chain. Where do you think this intersection lies between intersection runs between privacy and these regulations? What do you see happening there, actually?
Yeah, I think there are two major forces competing in this direction. One force is like the government focus force. Like we want the government to be aware of everything and know everything. And this force is in favor of privacy is bad. Privacy will allow terrorists to fund terrorists or terrorism or stuff like that. And privacy shouldn't be possible, right? And this is one force. The other force is that is actually more reasonable and more like privacy is not an option. Like you cannot have your financial data everywhere. And this is the historical context for that. Like when people started when technologists start discussing secure HTTPS, right? And HTTP was like everything is transparent.
Yeah.
When you type a password, your password is transparent to an attacker, to a man
Yeah.
in the middle attack. Then comes technology say, you cannot do this. You're actually adding more risk and more damage if you're allowing this internet traffic to be unencrypted. You need encryption. You need privacy to maintain the user's security. So it was a discussion between everyone, two forces. One wants everything transparent for the government to have their clause and everything. And the other force saying is that no, privacy is critical because if you avoid privacy, the damage will be more than anything else. And personally, I think regulations are slowly moving into the same camp. Privacy is important. You cannot have companies aggregating data like it used to be.
Yeah.
Like Google, Facebook becomes this company, becomes this like massive companies by aggregating data.
Yeah.
And you have regulations like GDPR and the California Information Act that protects users' data. So I see the logical extension of these regulations would be regulations that protect privacy and in machine learning and in crypto. So it can take a while, but I'm optimistic about the future. I think within 5 to 10 years, we will have seen regulations that protects privacy. And now this fights or conflicts like tornado cash and stuff like that will be more manageable to figure out.
Oh yeah, fantastic. And finally, what are the projects that are that are going live in the near future that maybe also products of what you call like the products of Allianz, which you are really excited about and seeing in the coming months to year or so?
Yeah, there are so many products that I'm excited about, but if I limit myself to the privacy theme, I would say Inco Network is one of my favorites because they allow FHE to be used on a chain, which is a new trend. I am personally excited also about Aztec, despite not necessarily being an alliance company, because they have done an amazing job on developing this technology. There are so many projects that I'm connecting with now and that will be joining our alliance that I cannot speak about. But there are project building an MPC technologies, there are project building and TradeFi applications or like DeFi applications that are private. In the market now, you have Penumbra, that is a company that is building private transactions or private DeFi on Cosmos. You have Renegade that is using MPC for dark pools, but there is many more coming to the market. And I'm expecting even some of them to come into the Bitcoin market. And this is a separate competitive discussion.
Yeah.
But yeah, there is a lot of companies. And in general, in Alliance, I love to work with founders building these. So if any of your listeners are developers who are building these technologies, please reach out to Mohamed Fouda on Twitter and we can discuss. And I will provide you honest feedback about your project.
Yeah, we'll definitely make a shout out to reach out to Mohamed because I think Allianz is supporting great projects and it would be fantastic for builders who have guidance, people like you. And finally, it's about Allianz. Is Allianz goal is to become the Y Combinator of Web3 blockchain space?
I think we are already there. Like Alliance so far is well, like Y Combinator is focused or like originalist accelerator. They accept companies from all three. We are very focused on Web3. We are striving to be the best accelerator. We like or the most founder friendly. And our thesis is simple here. We have been founders ourselves. We have been in the space since 2012, 2013, most of the team. And we believe that the best support for founders will come from founders. So our thesis is that when you get the best founder together and organize them in some form as a DAO and give them exposure to help each other, that will be the best format possible. And Alliance so far has been successful in this mission. We started our 12th cohort 2 weeks ago. And the quality of the founder we are dealing with are like amazing. So we are trying to get more founders to this community and expand the power of these teams to the world. I am very optimistic about Alliance and I think we are on the right track and I advise every founder who wants to make it big to join Alliance.
Oh yeah, fantastic. And great to hear that. It's a fact that without being a founder, how would you understand the situations of the founders and how would you be able to guide them? And in that sense, this is the right place for founders to be to get the best advice and the best. Wish you all the best for Allianz and your journey as the head of research. And this would be a great point to conclude the conversation. And it was fantastic talking with you about the privacy. And I'm looking forward to our next conversation about Bitcoin Layer 2. So it's one topic you are really passionate about. And I loved reading your another blog where you compared the software abstraction stack of CK with that of AI and how it's evolving in almost in similar path.
I would love to discuss again on other conversations. And thanks for having me today. It's always a fun discussion to discuss these topics.
Yeah, thank you, Mohamed. Thank you for being here and have a great day too.
Yeah, same here. Thank you.
Thanks for tuning in. If you are keen on getting deeper insights about Web3 tech, our newsletter, Just the Metrics, is just what you need. It's packed with valuable information and it's completely free. You can subscribe by clicking the link in the video description. It's a great way to keep up with the latest in the Web3 space straight to your inbox. And before you go, please hit that like button and don't forget to subscribe to our channel for more updates and insights. Your support is what keeps these videos coming. So see you in the next video.